Hello everyone. After sleeve and quarter joints, let's start next topic of this chapter and next topic of assembly disassembly drawings, Gib and Quarter joints. Let's see what is Gib and Quarter joints. This joint is used to join two rods of a square or rectangular in cross section. It means now for this joint, cross sectional area will be rectangular or square. The end of one rod is forced in the form of a fork or strap. The height of the other rod is increased for compensating the loss of material in making the slot for quarter. The gib is made up of mild steel and has the same thickness as that of the quarter. The gib has projections at the top and bottom ends which act like hooks. While connecting rods, the gib is inserted first and pushed towards the end of the fork, and then the quarter is hammered over. The tapering side of the gib and the quarter met with each other while their outer sides are parallel to each other and perpendicular to the common axis of the rods. Hence, when a gib is used with a quarter, the opposite faces of the slots in the rods are parallel to each other. This joint is useful to fasten connecting rod of a steam engine or marine engine. Now I will try to explain it using model of this joint. So this is the first rod or first element of this assembly, fork end. As you can see, the cross sectional area is similar to square, so square cross section, or for this section it is like rectangle, so rectangular or square section. So from the front, this is the front view, and from the top you can see this hole. So this is the hole for quarter and gib. Next element, second rod, fork end. So again for fork end, from the top you can see this is the slot for quarter and gib. Then other two elements are gib and quarter. So this is a quarter, this is a gib, and this side of gib and the same side of the quarter is common or matching side. Other two sides are parallel to each other and perpendicular to the central axis. Also, slot for gib and quarter on rod end or on both the rods, fork end and eye end. Generally the ends are perpendicular to central axis and flat, because the tapering side or tapered side is common for both and matching side is tapered side. So you don't have to worry for the taper in this joint. Now for assembly, first of all we'll draw this part. This part means fork end first, then eye end. So we have to insert this eye end like this in the fork end. Okay, so these are thermocol plates, right? So after inserting this end or rod or eye end, this is the final assembly. Then after doing this, now we can insert this gib like this in the quarter slot, like this. Okay, and then we'll push it like this towards eye end. So we have to push this gib towards eye end, and after pushing it in this direction, these projections are going to lock this gib on fork end. Then we can hammer this quarter like this. So this is the final arrangement or final assembly of this joint, right? Now from the front, this is the front view. From this side this is the side view of this assembly. So the cross sectional area is a square, then this is for fork end, these lines are for gib, and this is last quarter. And from this side, again this is the side view, square, then rectangle, then quarter, then gib, right? And from the top, this is the top view of the assembly, right? Now other thing is its clearance. So how to decide amount of clearance, or how to draw clearance in the assembly? Again, I'll try to explain it. This is my first rod, fork rod or fork end. Then this is the second part, second element, second rod, eye end. So we'll insert eye end like this. Now the gap calculation depends on the distance. This is the distance. So for the slot, this is the distance on the fork end, and for the slot, this is the distance on eye end. It is clear that the slot width is same, but it's not in a line. It means we'll have some clearance like this. These are clearance, and then we'll insert gib like this, and then we'll insert quarter on this joint like this. Okay, so finally this is the view, this is the final view. And in this assembly, okay, now it's better. In this assembly, these are clearance, first clearance, second clearance, and this is third clearance in blue color. So this is the amount of clearance after assembling all these parts of this assembly. And the view in front of you is similar to full sectional view. So in full sectional view, we have to show section portion for fork end, for eye end, and we don't have to hatch for quarter and gib. So this is the front view, sectional front view of Gib and Quarter joint full in section. Now we'll start a problem. So first problem in Gib and Quarter is from pictorial view. So from pictorial view to orthographic views. Problem statement: the figure shows the exploded pictorial view of a Gib and Quarter joint. Assemble these parts correctly and then draw the following views to scale 1:1. First, front view full in section. Second, right side view. Third, top view. Print the title and scale used. Give 6 important dimensions. In the problem figure, fork end and eye end, these two rods are given in pictorial form or pictorial projection. For Gib and Quarter, given figure is orthographic. So we'll start from fork end. First, fork end SQ30. Different dimensions are: first is SQ30. SQ30 means square of size 30. So for fork end, the dimension or size of the square is 30. So 30 by 30 is given to us. Second, total length is 112. So this length from this corner to this corner, total length is 112. Then 30. Okay, so if this width is 30, this must be 30. Then we have 20 distance of inner corner or inner face from this side. So this is 20, this is 20 in the figure, and then after 27. So for quarter slot, this distance is also given to us 27. So from this corner to this point, 27, and slot width 35. And what about upper height? Okay, this height is 10, this is also 10. So 10 plus 10, 20, 20 plus 30, total must be 50. Yes. So this width, this height is also given to us 50. So total 50, upper 10, lower 10, and middle portion of size 30. Okay, one more thing is given to us, R5. Yes, so in my model these corners are sharp corner, but in your problem figure these are rounded or fillet corners. So we have to use R5 fillet radius for construction work. Next, I end. So for I end again SQ30. So the size of this rod is 30 by 30. Then 30, 35 and 10. Okay, 10 is the width, 10 is the thickness of quarter slot. So for I end, this is 30, this is again 35. So quarter slot width, quarter plus Gib slot width is 35 for both, and this thickness, slot thickness, is equals to 10. Then for Gib and Cotter, different dimensions are 53, 53, 10. So upper half 53, lower half 53. Then 10 is its thickness of Cotter and thickness of Gib, 10. Then for central plane, width of the Cotter is 20, width of the Gib, this width is 12, and these are extra additional projections of 10, 10 each, and again corners are rounded. Okay, and okay, so this height is 50 and this is 76. So 50 and 76, so 76 minus 50 by 2, 13, total is 26, so 13 up, 13 down. So these are different dimensions for the given problem. Now for construction work, again we have to start from fork end. So for construction work we'll start from fork end, then we'll insert second end. Second end means we are going to insert I end on the fork end, then we will insert Cotter and Gib in this assembly. So final figure or final view will be like this, something like this. So in this figure, this is fork end, this is I end, Gib and Cotter. Opening of Gib on I end side and Cotter on fork end side. So this is the final view, front view, full in section, which we have to draw. Now in the sheet, we will start from its front view, then side view, then top view. So we have to draw right side view, means from the right side on the left side. So after suitable distance or suitable gap for its side view, we will start its front view. So draw first line for its front view, that is center line for front view and side view. Right. Okay, so this is my second XY line, this is my first XY line, reference line, vertical XY line, and this is the center line for its front view. Space for side view, space for front view, and space for its top view. Now in the front view we have to start from its fork part. So SQ of 30, we'll start from square of size 30. So after suitable distance, again we have to start from suitable distance for dimensioning and for naming. So this is the gap which we have to take. Then this is my first point, now from this point, half of 30 up, half of 30 down. So half of 30, 15 up, and half of 30, 15 down, parallel to vertical line. Then again after suitable distance, extension of 10 and 10, because this length is not given to us, we can take any distance. So after suitable distance, again suitable means as per space available on your sheet. So as per space available on your sheet, you can extend this end and second end also, right? So again, after suitable distance, total 50 means additionally 10 up, 10 down, right? So 30, then total 50, 10 up, 10 down. Now length of this part is given to us 112. So from these two corners, from upper and lower corner, line parallel to center line for 112. Like this. Then we have to mark its inner part also. Inner part means after 20. After 20 means again from this point after 20. So 20 from this point, 20. This is the point, and 20. And line parallel to center line again. Right. So this is the first element of this assembly, fork end, for which any distance, then from this corner to this corner 112, this is 20, this is 30, this is also 30, and we can erase this also, right? So this is first rod or first element of this assembly. Second is rod end or eye end. So eye end means we have to insert eye end like this. It means again we are free to take any length, because total length of the eye end is not given to us. So in your sheet, just try to count the length. Count the length means for rod end, given length is 30, then 35, then any. 30, then 35, then any. So for slot, these are slots. This is 30, this is 35, then any. So in fork end, total available length is 112 minus 20, that is 92. So we are free. So in this case, we don't have to worry for the length. Just extend it for 10, 20 or 15 mm as per space available on your sheet. Again, if you have enough space, you can extend. Otherwise, after this corner, 10 or 20 or 15 mm. Now let's mark slot on fork end and eye end. So for fork end, the distance is 27. So from this corner, the distance is 27, and quarter slot 35 for fork end. So for fork end, these are limits, or these are dimensions, right? Then for eye end, 30 and 35. So from this point after 30 and then 35. So now we have to mark 30. So from this point we have to mark 30. This is 30, this is 30. It means for fork end 27, for eye end 30 minus 27, this additional length or this clearance will be formed, and the difference or clearance, amount of clearance is 30 minus 27, 3. Similarly 3, 35 from this point means 3, clearance of 3, right? Now next we have to insert Gib and Cotter. So again we know that we have to insert Gib, then we'll insert Quarter, but this is the assembly, this is the assembly, this is clearance, and this is also clearance, and tapered side is common. So we have to start from this section. This section means from this point. So the space available, this is the space available for Gib and Quarter, means we have to use this common space. Again, in this figure, from this point to this point, it means from this point to this point, this is the common space available, which is equals to 35 minus 3. So total width available 35 minus the clearance 3 is 32. So the common width available is 32. And for Gib and Quarter, if you fit the Gib and Quarter, again total space available will be same. It means 20 plus 12 is 32. Yes. So we'll fit Gib and Quarter in the common space available of the common space available on the combination, on the assembly. So from this point, for Quarter, 53 up, 53 down, and similarly for Gib, total is 76. So half of 76 up, half of 76 down. So we'll start from Gib, from this point, 53 up, 53 up, and 53 down. Okay, so I have to change this line because I don't have enough space for the Quarter. But in your case, please check whether you have enough space or not. Okay, so 53 up and 53 down. Then, okay, width of the Quarter or thickness of the Quarter. Thickness is 10, but central width is 20, and taper is given to us, but we don't have upper and lower width. So what to do in this question? Again, it's a very interesting question. Okay, so central width of the Quarter is given to us 20, length 53 plus 53, but amount of taper or angle of taper is missing. So general amount of taper, we know that general amount of taper is 1:30, around 1:30. So we can calculate upper and lower width of Quarter using 1:30. 1:30 is equals to additional length or extra length by total height, because this angle is equals to 1:30. So extra length divided by total height is equals to taper 1:30 or 1:30. So say that amount is x, and for upper half it is 53. So x is equals to 53 by 30, say 2 mm. It means upper width of the Quarter is 2 greater than mean width, and lower width of Quarter is 2 less than mean width. So 20 plus 2, 22, 20 minus 2, 18. Now we can mark 22 and 18 for Quarter. So 22 and 18, right? Okay, and this taper or amount of taper is same for Gib, right? So the taper is common or same for both. It means we don't have to worry about the taper. Simply we'll project from this point, we'll start projection work or drawing work of Gib from this point. This point means 3 back. It means intersection of this line. After 3, this is the point, right? So from this point again, upper half total 76 by 2, lower half 76 by 2. So from this point, okay, one more thing, we are in this point, so we are here. Now this height is 50, this height or gap or say length is also 50. So from this point, half of, sorry, it's not 50, it's 25. So 25 up, 25 down, then 10, 10, then up, down, and then back, then back. So from this point, total 25 up, half of 50, total 50 down, half of 50. So total is 50, total is 50, then 10, 10. So from this point we can mark 10 like this, 10 like this, then again total is 76. Here the total height is 76. Okay, so yes, this total height is 76 and we have 50 with us. So 76 minus 50, 26, 26 by 2, 26 by 2. So 13, 13. Now the height, additional height is 13. So from these 2 points we can draw lines of length 13, 13 up and 13 down. Now simply we can draw lines parallel to center line up to quarter. So from this point, line parallel to center line up to quarter. From this point, line parallel to center line up to quarter. Right. Now we can use dark pencil and we can decide limits of hatching. So we have enough space, so we can extend it also. So after extension, these are limits for hatching. Again after extension, these are limits for hatching. Right. Now for forkand, these corners are sharp corner as per problem figure. These are sharp corners. No, we have fillet radius R5. Okay, so for this corner and for upper corner we'll go for R5. R5 means from this point 5 up, 5, this is the center, 5 down, 5, this is the center. Similarly for these two corners, 5 and 5, 5 and 5. Okay, so these corners are sharp corners. Yes, no, again my mistake. These are rounded corners and better. Okay. Then on Gib, again These corners are rounded corners, but we don't have data, so again we'll go for R5, 5, 5. Then hatching part. Okay, then next it's side view. So for side view again we have to draw lines of projection or projectors of front view. So we can use limits of front view like this. Right, and similarly we can draw perpendicular lines also, perpendicular to first reference axis or perpendicular to xy by extending all important limits or corners, or by drawing lines from all corners of front view. And a reference line for front view and top view. Okay, so this is the space for its side view, and for side view we know that the section is similar to rectangle and square, combination of square and rectangle. So again we can draw center line or line of symmetry for side view. So this is the line of symmetry for side view, center line or line of symmetry for the side view. Right, so from the center line we will start from that side, means for I end the section is square. Square means 30 by 30. So from the central point 30, 15 up, 15 down, total is 30. Similarly 15 and 15. So total 15 and 15, 30. These are limits. So first square of size 30 by 30 for I and like this. So it's a square of size 30 by 30. Then for fork end 10 up, 10 down, and the width is same 30. So again up to next limit 10 up, 10 down. And then for quarter and gib, and we are observing from this side, means gib is on facing side, so limits of gib are visible limits, and the thickness of both gib and quarter is same, 10 10. So again from this point half of 10 5, half of 10 5, half of 10 5, half of 10 5. Right, hidden inside the rectangle. Inside the rectangle means inside the fork and eye end, and then dark visible throughout quarter, and this is the edge of Gib, edge of Gib, right. And from that side means from this side again, view of I end is sectional view, so we have to hatch it. Okay, then for its top view, again for its top view we can use projections, or we can start from the top view. Top view means without using side view, we can also start from the center line. So better is first we can write a center line. Okay, no, we'll use projections of side view because this method is better. I guess it's better, right? So from this point at an angle of 45, or you can rotate also from this point. This point means from the common intersection point of first reference and second reference, this much as arc, and you can rotate. Okay, so from the top, first of all, these are my limits of the assembly for fork end and for the rod end. So, and the width is constant throughout. Okay, so this is the top view of the assembly. Now for quarter and gib, these are limits. This is the limit of quarter and this is for gib, and the thickness of quarter and gib. So these are lines of thickness. So we'll start from this point. For quarter, this is the top view of quarter. Then for gib, extension for gib. So quarter and gib. Then from the top, this clearance means this edge with clearance is also visible. So the slot, extended part of the slot, this is extended part of the slot on fork end is visible. And for eye end, hidden line. Then for bottom width of the quarter, again this line representing thickness of bottom width is also hidden. So this is a hidden line, it's a hidden line. And yes, and for this part again hidden line, because that edge is not visible from the top. and edge of fork end. This is the edge, so dark visible line, and for last end of fork end, dark visible line. And one more mistake, we have to show sectional representation in top view also. So yes, so in place of dark straight line, we'll show ends with sectional representation, right? Next, dimensioning. Then scale used and symbol of first angle projection method. Sorry for the missing part, writing work, and the second circle of the symbol, because space in my phone was not enough. So this is the final assembly. This is the final assembly of Gib and Quarter front view, full in section. Then from that side view like this. So this is the side view, and from the top view, this is the top view. So this is it from my side. Now I'll request you to please draw this assembly in your sheet. Please start from its fork end, then insert eye end, then quarter, then Gib, then project its side view, then top view. Do all dimensioning, write headings, front view, full in section, right hand side view, then top view for top view. Scale used 1:1, projection symbol, first angle projection method, and overall heading assembly of Gib and Quarter joint. And if you have any doubt, any problem in any of the topic of engineering, graphics, class 11th, class 12th or university scheme, please write your comments in the comment box. Thank you.